In section 3.1, we're going to be solving multi-step linear equations. But before we get into doing some of those examples, I do want to do a little bit of review for simplifying and evaluating to make sure that we can differentiate between simplifying, evaluating, and solving. So the first expression I have written here, we're going to simplify it. And just to review, simplifying is when we want to rewrite an expression in a equivalent way, but with fewer terms. And we're going to use the different properties of equality and identities to do that. So with this particular expression that we have here, I'm going to start with the distributive property. And then once I've used the distributive property, I can rearrange the expression so that I can combine like terms and simplify. And now my expression, it is equivalent, but instead of having multiple terms, I only have two. To evaluate an expression, instead of just trying to rewrite it with less terms, I'm actually trying to evaluate, to solve, to get a final value, a single answer, usually a numerical answer. In order to do this, I need to know what the value is for the unknown number. And in this case, let's say x is 2. I'm going to use the same expression. And since x is 2, if I replace x with the number 2, I can actually now use the order of operations and solve to get a final answer. And in this case, happens to be 2. And the last one is what we're actually going to be working on today, which is solving the equation. And so I'm going to start with the same one here. What makes it an equation is when I have it equal to something on the other side. And by having it equal to something on the other side, let's say -9, I'm able to still do the same thing I did on the left side, simplifying it to write it into as few terms as possible. And then from there, find ways to actually isolate the variable. And isolate means to get the variable by itself so that I can determine what is the value of this variable. What number is that variable equal to? And that's the thing we're going to focus on in this lesson. We have looked at how to solve one-step equations. In this lesson, we're going to look at how to solve two-step equations. And this down here is actually the steps that we're going to use. The first thing we're going to do is what you just saw happen up here. And I'll move this down so we can kind of look at what we have done and what our rules say here at the same time. And so the first rule, or not rule, but steps, the first step says to simplify each side of the equation by distributing and combining like terms. That's what we did here, so that we end up with a two-step equation, which is our focus in this section. Step 2, once we have that two-step equation, we're going to use addition or subtraction to separate or isolate our variable so that we have the variable on one side and the constant term on the other side. And in this case, when we're in step 2, it is okay if the variable has a number attached to it. That number isn't a constant, it's a coefficient at that time. A constant is a number that's by itself, not attached to a variable. So we're going to use, as mentioned, addition or subtraction to move that constant term. So in our case, our constant term is the 4, and we need to use our inverse operations, inverse is opposites, to move it to the other side. And the inverse operation for addition is subtraction. So we're going to subtract 4 from both sides. And when we subtract 4 from both sides, we end up with negative 3x is going to equal negative 13. Once we have that done, we can move on to step 3. And step 3 says to use multiplication or division to eliminate the variable's coefficient. The coefficient is that number in front of our variable. And sometimes the coefficient might not be there. You might not see a number there. If that's the case, your coefficient is 1 and you might be done. In this case, we have a number there, and this number is actually being multiplied by our variable, negative 3 times x. And so the inverse of multiplication is division. So I'm going to divide both sides by negative 3, which will cancel out the original coefficient because negative 3 divided by negative 3 is 1. And that's going to leave me with negative 13 divided by 3. I'm going to go ahead and just leave it as a fraction. You could rewrite it as a mixed number if you'd like. But here we have our final answer, which is x equals 13 over 3. Now notice that there are 2 more steps. Step 4 is to check your answer, make sure that it makes sense in context to the problem. This is really important if you're looking at a word problem. And then the 5th step is for word problems. You want to actually answer the question. You'd be surprised the number of times that I have students will do all kinds of work and not actually answer the question that was asked in the problem. So you do want to make sure that you make sure the answer that you receive makes sense in context to the problem. For example, if my problem is asking me how many people can fit on a bus, can I have 13 thirds of a person? No. So I want to make my answer make sense in my problem. Does that mean this answer is wrong? Probably not. But I do want to make sure my answer makes sense. I might need to round my answer so that my answer makes sense in context to my problem. So keep that in mind.